Hey guys, today we're going to talk about congruent polygons and some special things we have going on with them. So congruent polygons, what it means to be congruent means to be like equal in measure. So when you're talking about different polygons that are congruent, that's going to mean they're the exact same shape and the exact same size. So everything about them is exactly the same. So like you might have a triangle, looks like this. A congruent triangle would be, and mine might not be perfect, but should be the exact same. This one's a little too wide. Be the exact same. But like your shape could go through a different transformation, like we could be a reflection maybe of the triangle. It's still congruent, or it could have been a rotation of the original triangle. Key thing is it's the same shape and same size. It just might have a different orientation. It might have been reflected or rotated. But it's definitely not going to have something like this happen where it's kind of getting stretched out. Then they're not congruent. Or if it became larger, then those triangles are not going to be congruent. So it needs to be the same shape and size, but it could be rotated around or reflected. Now when we have congruent triangles, there's some special parts. And we're going to go back to an old vocabulary word here. And we're going to talk about the corresponding parts. So we talked about corresponding angles way back when we were doing transversals. So corresponding parts of different shapes are going to be the parts that match up together. And for these two triangles that we have here, these are all of the vertices. We have triangle ABC, triangle HFG over here, and we have these measurements, 80 degrees, 60 degrees, and 40 degrees is our angles, 80 degrees, 40 degrees, and 60 degrees is our angles here. And we know side lengths, 12, 23, and 18. Then this one's 18, 23, and 12 like that. So if these two triangles are congruent, then that means, and we'll start with the angles, every angle in this first triangle is going to have one angle that it matches up with in the other triangle. What I mean by that is like the 80 degrees, that goes up with the other 80 degrees. The 60 over here, that's going to go with the 60 over here. And the 40 degrees would go up to 40. So all the angles match up. But in order to be congruent, all the angles have to have a pair. And there also has to be pairs of sides. So the 12 goes with the 12, the 23 goes with the 23, and the 18 goes with the 18. So since everything has a corresponding part that it's congruent with, that's what makes these two triangles congruent. Now what we can do when we know they're congruent, and that's just by checking to make sure everything has something that it pairs up with, we can write what we call congruence statements. Congruence statements. And when you write a congruent statement, all you're doing is like stating the pairs of congruent parts, the corresponding parts. And what I mean by that is, like let's say we have angle A, that's the 80 degrees right here, this angle. Angle A, that goes with angle H over on this other triangle. So they go with one another. And since they're congruent, they have the same measure, we're going to use that congruency marking that we did way back when. So angle A is congruent to angle H. This is one of the congruent statements. Angle B is congruent to, well, B is the 60, that goes with the 60. So it goes with angle F. And angle C, that goes with angle G. The 40 goes with the 40. So we're just listing the parts that are congruent, the parts that are corresponding. So that's all the angles, but we also want to list the sides. So side AB, remember how we notate that with the line above. Side AB, well, that went from like the 80 degree angle to the 60, like those vertices. So go from the 80 to the 60, that would be HF. So AB goes with HF. And once you have the angles written, you can actually use them to write the other statements. Since A always goes with H, wherever you wrote an A here, you're going to put an H. B goes with F. So since you had AB, it would be HF, because AB, HF. So once you have the angles down, the rest of it's kind of a little bit easier. So let's say we go from B to C, that side down here on the bottom, the 23. So BC should go with, well, B to C would be like F to G. So it goes with side F, G. so it goes with side FG. And then our last one would be AC, or you can call it CA. Either way is okay. So if you're going from C to A, that would be like going from G to H. So these are your congruent statements all here. These are your angles up here. These are the sides that correspond with each other. And then lastly, what you're going to do, and the order matters a lot with this, is we're going to say, or triangle ABC, so we can use that triangle symbol. Triangle ABC is congruent to, and the order matters here. Since A corresponds with H, we're going to say it's triangle H, B corresponds with F, so it's HF, and C corresponds with G, so triangle ABC corresponds with triangle HFG. The order matters here because that's telling you the corresponding parts, and if you weren't given the actual triangles, if you were just given this statement, then you can still tell what corresponds. The A is going to go with the H, the B is going to go with the F, and the C is going to go with the G. So this statement's really important to have the order in the right order. All right, let's do another one. We're going to work with a quadrilateral, and all we're going to do is write congruent statements for the two figures. So the figure we have here, and you're going to be using the slides with these, so I'm not going to write every part of these. You can use the slides to look on. I'm just going to draw the two shapes, and then I will list the vertices of them, but I'm not going to draw the angle measurements in. You can use the slides to get those down. So we have this, then we have U, V, X, and this is a W up here. And so if you're looking at your slides, what you want to do to check if they are congruent, you want to make sure every angle in the figure to the left matches with an angle in the figure to the right. So in the figure to the left, this is 36 degrees, and there is a 36 degrees in the one to the right. This is 104. If you look to the one to the right, there is 104 degrees. 108 matches, there is 108, and 112, we have 112. So all the angles have another angle that they correspond with, and then we want to check the sides. So this side up here would be 30, and there is one on the other quadrilateral that's 30. This side is 31, and there is one on the other quadrilateral that's 31. And then both of these sides are 12, and there are two sides that are 12 over here. And since they're both 12, it can be a little tougher to tell what they correspond with, but we're going to use the angles for that. So let's start out first by just writing the angle congruent statements. So let's say we start with angle O. Angle O is the 104. So if you look at the other quadrilateral, 104 comes at angle X. So that's going to correspond with angle X. If maybe we do N next, angle N is 108, and that corresponds with angle W in the figure to the right. Again, you'll see that in the slides that you should have opened up right now. Let's say we keep going around, we do angle Q next. So angle Q is 112, and that's going to correspond with angle V over here to the right. They both are 112. And last, we have angle P up here. That's 36 degrees, and in our other shape, the 36 is at angle U. So these are all the corresponding angles. Let's go ahead and do our corresponding sides as well. And I'll do them right down here. Let's say we go from N to O. So if you go from N to O, I'm just going to use the angles. N goes with W, O goes with X, so NO would be WX. That also is NO here, WX. So that 12 goes with this 12 on this side. And let's say we go QN now. So side QN, or Q to N, would be V to W. So side QN corresponds, or is congruent to VW. They correspond with one another. And let's say we keep going around. We're going to do PQ. That's this side. PQ would be UV. So these sides are congruent to one another. They correspond. And last but not least, let's go right here. We're going to do side OP. That's our last missing side. And OP is going to be congruent to O to P would be like X to U. So that would be side XU over here. So these are all the congruent sides. They're the ones that correspond. These are the congruent angles. They are what correspond. And the last thing you want to write is a congruent statement just for the two figures in general. So let's say we did ONQP. ONQP. That is going to be congruent to ONQP would be XWVU. So this lists all the corresponding parts that go with one another. From there, you could actually write all these statements without the two shapes. And we'll do an example of that on our next one. All right, so our next question, we are given actually triangle JWP is congruent to triangle HCD. And we want to write congruent statements from these. So we don't have a picture to reference. We just have the congruent statement that's given to us. But again, the order that we write is very important because it's going to tell us what corresponds. So from this statement, we know angle. Well, each one of these points is going to have an angle. So angle J we'll start with. That's going to correspond and be congruent to, well, J was first, H is first, so it's going to go with angle H. And this is why the order is so important, because it's going to tell us what corresponds. Angle W, well, that's going to be congruent to angle C because they correspond with one another. And angle P, that's going to be corresponding with angle D, which makes them congruent. So these are all the angles that are congruent. They're all the angles that are going to correspond with each other. We also can do the sides. Let's do JW first. So side JW, that's going to correspond with HC, so that makes them congruent. JW is congruent to HC. We could do WP next. So WP is going to be congruent to CD, and that's because they correspond with one another. And then we want to do PJ. So our side PJ is going to go with DH. DH. And that's because they correspond with each other. They're written in the same order, so they will be congruent. So whenever we were to find these two triangles, if we had a picture of them, this is everything that would go together. And we have one more with a quadrilateral, same type of problem like this. And this is why the order of those congruent statements is so important. It tells us a lot of information just by looking at the statement. This can also be really useful if you have a problem with two different shapes and you can't really tell which points should go with one another, because maybe instead of having numbers given to you, you have expressions or variables. This will help you tell what corresponds with one another. So always rely on this statement here. So from this, if we listen to the angles, we know angle D is going to correspond with K. So that means they're going to be congruent. They're going to have the same measure. Angle E corresponds with L. Angle E is going to be congruent to angle L. They are corresponding. F is going to go with M. So angle F is congruent to angle M. They'll have the same measure. And angle G is going to be congruent to angle N. These are all the angles that will go together. And let's do our sides now. So DE, that side will be congruent to KL. The DE goes with the KL. EF, that side will be congruent with LM. FG will be next. This side is going to be congruent with MN. And then we'll do GD. Don't forget that last one. There should be 4 sides. So GD will go with NK. And that's because all these pairs correspond with one another between the two shapes, so that'll make them congruent. So right now it's just about recognizing what goes with what are the corresponding pairs, and those pairs will be congruent with one another. Once we're able to do this, then we can start getting into finding missing measurements between different shapes. So go ahead and practice some of these on your own, and have a nice day.